Hello, good day. This presentation is about the risk on low voltage network of the Gupan Electric Company as part of the requirement for professional engineering management modules. The main aim of this case study is to review the current low voltage system of the Gupan Electric Corporation and propose a technical solution by referring to local and international codes and standards. The objectives are identifying the risks as well as the opportunities by producing managerial engineering service delivery plan by using different management tools and theories, to analyze the science behind the risk according to earlier research by Professor Dalziel and others, to understand the provision of IEC, British Standard 7671, the Philippine Electrical Code, and the National Electrical Code on Earth Fault Protection, earthing system, and create a technical proposal to reinforce the needs of technical training and seminars for key personnel, to emphasize the importance of IET, IEEE, and the academe for research and development, to justify the urgency of line-to-ground conversion from isolated earthing system. As introduction, we will ask the question, what is the problem? The problem is the isolated earthing system of the Gupan Electric Corporation. The network is only safe when there is no failure of insulation in the entire network of low voltage system. In the event when there is only one point of insulation failure in the entire network, the system is unintentionally converted to line-to-ground network. The next slide will make this clearer. Misconception of many electrical practitioners that ground rod will eliminate ground fault. But due to high resistivity contact of rod and earth, this impedes the fast operation of the protective device. On the picture shown, the installation is provided a ground rod which is connected to the extraneous metallic part of the system. Without the third wire or equipment grounding conductor, protective device will never operate when there is an insulation failure. Any human or animal who touches or made in contact with the metallic part of the pole, this will become a current path to ground back to the source. The research done by Charles F. Dalziel and John D. Lagan found out that 100 milliamperes for shock duration of 3 seconds can produce ventricular fibrillation. When the heart of man is in this condition, the survival of the victim is small. Ventricular fibrillation is an irregular rhythm condition of heart that results in rapid and uncoordinated manner that make heart inability to pump blood to the rest of the body. Professor Charles Dalziel is the inventor and patent holder of GFCI, or what we call as the ground fault circuit interrupter. He's also an IEEE Edison Medal awardee in 1972. The time and current characteristics of type B circuit breaker is shown on the upper right. For the purpose of illustration, 32 ampere circuit breaker will be used as an example. The chart in logarithmic scale says that 160 amperes or 5 times the rating is needed to instantaneously trip the circuit breaker from 0.1 to 5 seconds. To achieve this tripping current, the IEC or the BS7671 defined the maximum earth fault impedance. And on this particular example, this is 1.37 ohms. To analyze the coordination of the data from the chart in the table on the right, Ohm's law is used to show this relationship. 220 nominal volts divided by 160 amperes is indeed equals to 1.37 ohms. After careful consideration of the problem, the non-standard low-voltage network is established. The imminent hazard to the customers, the cost of line revamp, the personal training, and the threat to the franchise renewal of the business are the main obstacle as shown on the design business model canvas, highlighting the key points to mapping out activities and resources to better understand the business situation by visual overview of the strategies to solve the problem. Using business analysis tools like ADCAR, Porter's 5, Steeple, and SWOT are used to identify the threats and the present situation of the business, the need for change, the opportunity behind the problem, and the technical capabilities of key personnel to tackle the issue. With the aid of business theories that is relevant to present business situation, this will provide a strategic framework to effectively manage and motivate the team. The productivity and creativity of the personnel are the key element to the specific problem, thus targeting the correct theories to implement to enhance the organizational goal. The theories considered on this paper are carefully selected to complement the present scenario of the organization. Understanding on how to implement them should be the common goal of the management and all the stakeholders. So finally, the recommendations are training of key personnel from planning and design section, to hire a consultant to this specific problem, utilizing the center bushing of the distribution transformer as a potential neutral earth connection, adapt the TNCS system of IEC or 8711, define the maximum loop impedance and coordinate with the customer's protective device, conduct free seminars and trainings to private electricians and customers. The new line extension and revamp can have a newly designed low voltage network. Reconductoring the service drop conductor with the aerial bundled cable conductor. Formulate a program for graduate studies with partnership with academe for future development. Liaise with the regulator, the ERC, Energy Regulatory Commission, about the transition period or the time frame of line revamp. Coordinate with Board of Electrical Engineers and Electrical Code Committee for the proposed network to harmonize the requirements for earth fault protection. Consider outsourcing for speedy implementation of the project. Neutral conductor to ground to be hidden on a precast concrete pole to avoid copper thief issue. Newly installed distribution transformer can be 415 volt line to line Y connected to improve voltage drop per ampere per wire. Single phase customer can be connected to line to neutral by load balancing rule. Also considering installation of PMC 400 or pole mounted cutout for overcurrent protection and generator connection point for shutdown and emergency purposes. And finally, determine the earthing rod distance between the lightning arrestor and low voltage system neutral, which could be uh, recommended by external consultant or by further research. Thank you very much, and if there's any question, please email me for more information. Thank you. Have a good day.